In this video, we're going to look at voltage across capacitors. So that's talked about quite a bit. So we're also going to look at the voltage across a series resistor when it's with a capacitor, because it's important to understand the voltages across all components. And so it's changing with the capacitor as it charges or discharges. It also changes across series components. We'll look at that. So we have a switch here that will instantly discharge the capacitor. It'll make a direct connection to both sides. So you don't want to use real high voltage or high capacitance for this. But lower capacitance capacitors, we're going to use the 1000 microfarad and 5 volts. The current is low enough where you shouldn't do any damage. But here you can see we have a 1 kilo ohm resistor right there, 1000 ohm. Comes to the jumper. I'm going to use the jumper instead of a switch. And the positive side of the capacitor, because that's more positive. And then we got the negative side going there to that jumper, in this jumper. So it's like a closed switch right now. It's like I'm pressing that switch. When I pull it out, it'll be like I release it. So right now, you can see there's current flowing. That's because it's going through the resistor and then through the jumper. The capacitor, both sides are basically connected to the negative rail. It's discharged. We have a steady current. If I pluck the jumper, now it's like I released a switch, a push button switch. And you can see current went down over time until finally it went to nothing. So now the capacitor is fully charged. I can discharge it with the jumper like that. So we'll look at that with the oscilloscope too. So now we have my pocket oscilloscope right there. Voltage is 0. We're not measuring anything at the moment. Each square going up though is 1 volt, and each square going across is 1 second right there. And so the probes basically for this are alligator clips. So I just clipped them to jumpers right there. And let's put this one to ground first. And so that's a direct connection to the negative side of the capacitor. And in fact now also to the positive side of the capacitor. And so it'll have 0 volts across it, as you can see there. And that's to be expected. So now I'm going to remove the jumper. This is like I pressed a button to discharge the capacitor based on the schematic. And if I release the button, then we have the RC time constant right up there. And so I'll try to pause it right when it gets to a square. But this is basic RC time constant stuff. You can see it took 1, 2, 3, 4, 5 seconds to get fully charged. You know, it's slower at the end. It's very rapid at the beginning. That is the RC time constant. Now we can unpause that, get back to reading it, grab the jumper, and you'll see an instant discharge once I make a connection to the rail there, and I even saw a little bit of a spark. So now that we looked at the voltage across the capacitor, we saw it shooting up as it charges once we remove the jumper. Now we're going to look at the voltage across the resistor. And so all we have to do is move the red jumper right there with the alligator clip to it to the positive side of the resistor, and then our black clip with this green jumper there to the more negative side right there of the resistor. So now I scooted the oscilloscope over and we still got the jumper there. You can see we got 5 volts across the resistor. We got the red probe there, alligator clip to the jumper, I'm going to call it a probe, to that side of the resistor directly to the positive rail, and then the green one there to the black probe clip to the other side of the resistor. Then we have a direct connection to ground. So that's a 5 volt difference. It's as if the capacitor doesn't exist for the most part, just by bypassing it. So when we yank this jumper, we saw the capacitor went from nothing to 5 volts with the RC time constant curve. Now when we yank the jumper, this is the voltage across the resistor. You can see it's the same as that curve, except for in the opposite direction. Instead of rising rapidly at first, as the voltage of the capacitor does, the voltage across the resistor drops rapidly at first. That's because as the voltage of the capacitor rises, we have less voltage difference across the resistor, thus less current, and with less current, then there's less voltage change. That's why the voltage is taking longer. So that's how the voltage across a resistor works with the RC time constant. So If it's confusing, read up on it more. But this was the demonstration just to show that. So hopefully that helps if you find this confusing. So make sure you check out one of the other videos that I'm posting. Click like, subscribe, the bell, and all that. I will see you in the next video.